Everybody, or good afternoon. It's 2 o'clock where I live. My sense of time is very confused. It's been a weird week. This is Nick McPhee. This is Unhindered by Coding. Be here for 2 hours programming and stuff and things. Probably doing Manim today to make some more images, animations, because I think that was kind of fun and I'd like to make more of them. So I just spent the previous week, Monday through Friday, at Gecko, the Genetic and Evolutionary Computation Conference, which was in Malaga, Spain. I was not in Malaga, Spain. Let's see, Gecko, 25. So yes, it was in Malaga. I was here, so I was attending online, and that meant there was a 7-hour time difference. So things like the morning keynotes started at 3:30 a.m. Well, hello, Vincent. And the opening sort of welcome stuff started at 3 in the morning in my time. So it's been sort of a weird week, and I was getting up like early, stupidly early. And then it would all finish around noon my time. And then I would try to like function for a little while and then fall over on my nose. So I'm still, hello Eustace, wonderful to see you. So I'm still kind of recovering sleep-wise and feeling a little fuzzy, but it was good. And I'll actually try to start tomorrow's stream actually with a sort of quick overview of some of the cool stuff that I saw. I'll say that the big theme was LLMs and evolutionary computation. It's been a long time with Gecko and family stuff before that. So it's sort of fun to be back, even if I'm very fuzzy. And if anybody cares, Gecko next year is going to be in Costa Rica, which I think we have never been in Central America or South America. I think as far south as we've ever been is Mexico. If I'm remembering this correctly, in the Americas, at least. We've been to Australia. I did not make that trip, so I haven't been to Australia, but it's my plan to keep doing EC research and stuff. You know, this is a very common question. Sort of the when you're starting college, the question everybody asks you is what's your major. And when you're starting retirement, everybody asks you what you're going to do. And a common version of that is, are you going to keep doing research? And it's interesting. There are a lot of faculty that clearly put a lot of energy into research after they retire. And I don't think that's me. I'm not sure exactly what role all of this stuff will play after I quit. I sort of feel like I'm winding it down, but also I've got a ton of ideas. There's a lot of things I could imagine doing if I had time and energy to do them. I don't know, I think is the short answer, Vincent. I think this is something we're going to play by ear and see what happens. I think that, to be honest, I'm sort of pumped for it right now because Gecko, full of ideas. But realistically, I think there's just too many other things I want to do that won't happen if I don't do them. Whereas research in computer science will continue to happen without me. It's not going to be a big deal. I would hope to be able to contribute, and that would matter. But I don't think that. I think your point, Eustace. I don't think research defines who I am to me, or really to anybody else. But I think that research is a thing that I have done, and I have enjoyed doing, and I think I've done some good work that has, been useful. But I don't think it kind of defines who I am, and there are other things I would rather do, I suspect. But that doesn't mean I'm crossing it off the list, because I could imagine working on the EC system here, that maybe we stumble across something that's like, oh, that's probably worth writing up, and maybe I would do that. Maybe I wouldn't. I don't really know, but it would be fun to go to at least one more gecko. And Costa Rica's, um, in the grand scheme of things, fairly accessible. Uh, and it's a place that I've heard lovely things about and have never been to. So, Lee Spector, whose name has come up in these streams, is a big fan of Costa Rica. So, yeah, yeah, right. No, I don't think so. It takes me too long to finish one. So, uh, I've made several frameworks over the course of my life, and they all end up being large and complicated, and none of them ever quite reach a place that I would call done. But yeah, such is life. So yeah, so Gecko was good. Lots of LLM stuff and LLMs, both using LLMs to help with evolution and using evolution to help with LLMs and other neural network based systems. So there was a lot of that. Like I said, I'll try to have a summary of what I saw together for the beginning of tomorrow's stream. I'm still finishing some notes, but we'll see if I get there and I can say something about what I saw. But there was good stuff. There was good stuff. Okay, so what are we going to do today? Yeah, LLMs are a huge topic. And there were, there were people from a lot of different areas. There were like Google DeepMind people presenting work, connecting LLMs to evolutionary computation. There are people doing applied stuff. There are people doing more theoretical stuff. There's a lot of things happening and a lot of hybrid stuff. So like one talk that I saw was using generative AI systems and evolutionary computation in tandem to design crystals that can be used. So they're called co-crystals. So there's molecules that you can embed medically active things into. So they create kind of a matrix that you can put these medically active things into and increase the bioavailability of the drug. So one of the hard things in drug discovery is bioavailability. You find a chemical that in theory might do something cool, but can you get the body to absorb it and use it? Or does it just not absorb? Does it break down during absorption and end up being unusable because of that? Does it bind with something else and become toxic? I mean, there's a lot of ways that absorption fails. And a lot of drug trials end up failing on the bioavailability hurdle, which is something that often you don't really know the answer to till you're doing trials with people. So it's a hard part of the problem. And so finding ways to improve bioavailability or our ability to predict bioavailability, both those things matter, is pretty important. And this is part of why things like protein folding, if you've seen lots of stuff about protein folding, that's related. It's bigger than bioavailability, but it certainly impacts bioavailability. So this one group was doing cool stuff to to evolve these crystals that you could then embed your active ingredient in, and the whole thing could be used to form a tablet. So being able to make good coherent tablets out of the medicine, that's also important because you can get tablets that fall apart, or don't absorb properly or don't dissolve properly. Lots of things can happen. And so that was actually quite cool as just an example of something that I saw. And yeah, there's a lot of computational chemistry in this stuff. And it's an interesting hybrid in that they're doing neural network stuff and evolutionary computation stuff, but it's also an example of the kind of hybrid you need to do if you're doing like serious application work, in that you've got to have not just computer scientists fiddling around with code, but you've got to have biologists and chemists and doctors, Oh, that's actually a good point, Eustace. It isn't really gifts, is it? Oh, that's So it was a no, not AVIs, AVIF. I'm not sure what the right language is off the top of my head. Um, uh, and it's a little weird because um, it is AVIF. It's a little weird because are people going to know that term? If you say animated GIFs, everybody knows what you mean. But if you say animated AVIFs, I expect there's a lot of people who have no idea what that is. So, well, if you have an infinite amount of time, there are lots of things to study. Absolutely. Um, and I'm here to tell you after 62 years, you don't get an infinite amount of time. It runs out on you. So, okay. So my idea today, like I said, I'm kind of tired and I didn't want to try to be too creative about the world. Um, uh, oh, yeah, weird. So, um, uh, was to actually go back to just the animations. I think we've got a good 2 point crossover animation. It would be nice to also have a 1 point and an end point, not necessarily for our documentation. Um, and that would be awesome. I mean, if you can make that happen. And sometimes people do it even in academia. I have a friend who's now retired at the University of Idaho who started off as a mathematician, then became a computer scientist, and then became a biologist, all within that university. And did very cool work in all three of those areas. So it can be done. It's rare, but it can be done. It does help to be independently wealthy if you can pull that off. So I don't know that we need for our documentations one and n point crossover, but like I don't even think. Let's see. Do we even unhindered? Let's see. That would be a linear, not push. Linear source, recombinator. Yeah, we have 2 point in uniform, but we don't actually have 1 point. And UMAD would be another one that I think would be good to visualize. And I suspect that our implementation of 2 point could be turned into an endpoint without too much difficulty. And that without too much change, we could make this essentially we turn this tuple of the two crossover points into a vector of an arbitrary number of crossover points that is at least one. And then this becomes a loop of some sort that swaps the parts. Yeah. So I don't think it would be that hard to do. But that's a tomorrow thing if we want to talk about that tomorrow. A today thing, it would be to actually just do the animations. So, that's not what I wanted to be. I wanted to be. Oh, that is where I wanted to be, right? Yes. Yeah, okay. That is where I wanted to be. And when I got here, I totally didn't remember where we left things off 2 weeks ago, 3 weeks ago. 3 weeks ago. It turns out there is a kind of dangling pull request that's basically ready to be finished, but isn't. And you'd think that Rust would protect us from these things, right? So this is basically in a happy place. Google Gemini Code Assist did point out two things that should be done. They're just wording changes, but they are broken and they should be fixed. So I think let's actually start by just dealing with those. I think I'd probably said, "Oh, I'll do that offline," and then 3 weeks later, I still haven't. So we'll just do them out. And first is at width here is just broken, so it should be with a bit rate of 15K. And that then should be resolved. And yes, and better, I think much better grammar checking also. I mean, because they can do context that's non-trivial, and so they can kind of see mistakes that extend across a couple of sentences or even paragraphs in a way that none of the prior tools could. I mean, their context was super local, and so I think the LLMs are actually pretty good at this kind of stuff. And then this is, what was the issue? Sentence states, is GIF instead of AVIF. So this should be an animated AVIF. So this is basically the LLM doing what Eustace did on the title slide. Boom. And then, yeah, okay. And so I think that then this all still, yes, Gemini is channeling its inner Eustace. And there's our thing, and woohoo, we get stuff. Okay, so I think that actually probably fixes that. So what have we done? We've just addressed Gemini. Let's see, I guess they write it this way. Code Assist suggestions. These fix a couple of wording issues. Boom, boom, boom. Or this fixes. This fixes a couple of wording issues. And stage and commit. Oh, I'm sad. I shouldn't laugh. I'm sorry. I know how frustrating that is. More like annoying Java stuff, because I know how happy that makes you. Okay, so I think that puts this in a reasonable place. Now, if I reload this, will this actually catch that those are resolved? Yes. Oh, it logged me out. No. Okay, I'm going to pop over into another window quick and relog into GitHub. GitHub.com. Yeah, boy, you can tell I haven't been doing this in a while, that GitHub decided that I was just like not even a person anymore. GitHub, what silliness you're up to. And two-factor authentication. And I say, yes, I'm me. Okay, and now reload that. Yay! It knows that I exist in the world. And I think I will just merge this pull request. Wah, wah, wah. And we can grab all, well, actually that just all will copy this. Yeah, we'll do that. And obviously I really should have done this in Markdown. If I copy the Markdown, then I will have better luck getting pretty things. There we go. That's better. Confirm merge. We have to do a bunch of Git tasks where one is to resolve a merge conflict, but they expect it to be resolved in some very particular way that I haven't been able to figure out yet. I think somehow my git config automatically inserting trailing new lines is messing with it. But there are 10 git tasks, and if you mess up any, you have to redo everything and reset the repo. And the merge conflict is like the 8th one. Oh, yikes. So this is sort of like in a game where when you die, you back up to some previous point, but it's a long way, and you have to wade through a bunch of nonsense. Plus, you have to ask the instructor. Yuck. Yeah, that is. I mean, would it, if you think it's your git config, could you just set up either temporarily disable your git config or set up a fake user to do the homework on, so that you're not starting with all of the stuff you have set up and are used to, and you're starting with a cleaner slate that would be more like what probably other students are starting with, because I could imagine your development environment is pretty highly tuned at this point. And if that tuning doesn't line up with their expectations, I could definitely imagine that that's going to be a pain. Yeah, I mean, it's a possibility. Sigh. So let's see. Then we will go back to main and whoa, what happened here? Oh, come on, really? Ignore that. Ignore. I don't know why that started happening again. It's very annoying. Well, if other people are having the issue, that may be that the faculty need to like just, figure something out. Because if it's just you, that's one thing. But if it's lots of people, door, boom. Oh, no, putting it there, not going to be good. Can I... What does drop commit do? Oh, there we go. Good job. So then actually I'm just going to do that. Boop, reset. And then fast forward main. Pull, fast forward. Yeah. Oh, and actually DS-Door, if I'd noticed, it was actually in the other branch. Yeah, so if at least 20 said something, then like you say, there could well be another 10 to 30 that have had the problem and haven't said anything or don't fully realize what the issue is. So, yeah. Yuck. Okay, so that takes care of that. And let's see, I want to get rid of this branch because I don't like having straggly branches. So, then we come back over here. Yes. Wahoo. Okay, so this was 2-point crossover, and I would like to also have an animation that does, I mean, if we start with just 1 point, we should also do UMAD, but that's actually going to be a little more complicated. So I think actually I'll start with just 1 point, and probably need endpoint. It's not clear kind of what that would be a place where your idea, Eustace, of having sort of a grid of crossovers might be nice to highlight the different number of crossover points as well as their location. Yeah, you strike me as the kind of person who'd be very annoyed about that 0.1 point. So, and not complaining. I'd be that person too. So, but it's also frustrating if you have to rewind, and you have to get the instructor's permission or involvement to back up. That's certainly frustrating. So so let's see. I think one point, or so actually maybe really the thing to do is to think about refactoring. Um, yes, I can totally imagine that you are that person as well. And as a faculty member, I'll say those people are pretty annoying sometimes. But they're often some of the most interesting students. The ones that are like whining about low grades, that's actually more frustrating because it's like, yeah, you didn't do the work and now you're going to complain about it. But, you know, good, strong students that are like arguing about edge cases is a little less frustrating to me, but different faculty have different attitudes toward these things. Okay, so it's been too long. Let me remind myself what the heck this even does. So, where is the main thing? I assume this top thing, construct, this must be the main, essentially, that we're constructing this scene. That makes sense because we inherit from scene, and so it's going to call the constructor. These define the two crossover points. Those are not great variable names. And we build 3 genomes, and then we fail if the genome length is 0. I don't know. Not entirely clear to me why we're checking this, because we set it to be 10 here. Yeah, I'm not entirely sure why we're actually checking this here. And then what does get top and get bottom do? Those down here. Well, this is the thing. People often ask questions when faculty are really busy, and it does sort of feel like it's maybe not the most useful way for any of us to be using our time. And as I've told many a student, when you're 30 or 40, that point will not matter in the slightest. It may feel like it's a big deal right now, but it will stop feeling like a big deal pretty quickly. So actually, what get top? What does this even do? Where is that defined? It gets an attribute. Oh, it's in MoObject. Oh. So okay. So these are graphical elements about the genes. The genes are MoObjects, and we're getting the top plus a little bit, so we're up a little bit, and the bottom minus a little bit, so we're down a little bit. So this is the beginning and the end of the line. The line starts at the top of the first parent plus a little bit and goes down to the bottom of the child, which is down a little bit. Well, the fact that I had to figure that out makes me think a comment would be in order here. These indicate, or specify would be better. Specify the top and bottom y coordinates of the dashed lines representing the crossover points. We want the lines to start slightly above the first parent, hence the plus 0.1, and end slightly below the child. hence the minus 0.1. Boom. Hey, Wagatha. Wonderful to have you lurk as always. I hope things are going well. So, that is lovely. And, you know, I'm all about lurking. Lurking is fine. There is stuff to be done in the world. Okay, so that tells us the top and the bottom lines. I'm not going to say, do we need this? Do we need this? Boom. And then, oh yeah, so this I think this was created by some LLM, and I feel like this is a thing that could probably be cleaned up because my memory is that this may not be doing everything we need it to do. Yeah, I think it is very vibe code. So, and I think one of the things that LLMs are not great at is things like edge cases. And logical structure. So yeah, this is because I started this with an LLM, and I think this code is still sort of largely untouched LLM code. So, so we're saying if the first crossover point is greater than 0, otherwise if it's equal to 0. So we're doing two cases that are whether that first crossover point is in the middle somewhere or off the left-hand side. And do we need that? Do we need to treat that separately? Because notice we don't treat... Oh, and then the second case is actually checking to see if the second crossover point is off the right-hand side. So can I easily do a get diff? So I assume you're saying do a get diff between lines 29 to 33 and 35 to 39. And I don't know that I know how to do that. Oh, well then let's have a look. Copy URL. Oh, go away all of the stuff. Oh, there's a desktop thing, but is there? I can do it here. Oh, so I would just paste the two pieces in. Oh, okay. Well, that's a thing I could do. So I would paste this in here and paste this here, and I would find the differences. Ho ho! That's nifty. Why, that's actually very cool. I don't think I knew that existed. And we can see that there is vast oceans of duplicate code. And the only thing that's different is the very first line of those blocks. And how does that differ? It says that we get the parent one. Oops. Oh, no, that wasn't what I wanted to do. Well, okay. This is, actually, I'm going to make this bigger. There we go. It'll be a little easy. The highlighting is a little awkward. So we're taking parent genes IDX minus 1, and that won't make sense over here because IDX minus 1 would be negative 1, and that would blow up. And we're adding IDX. Oh, we're taking the, yeah. So this is taking the midpoint between, yeah. So we're taking the left side, so we've got our two blocks. We're taking the right side of this block and the left side of that block, and we're taking the midpoint between them so that we're saying our line's going to go right between those two blocks. And over here, we're taking the left side of the leftmost block and uh, subtracting, so adding a little bit of buffer space and dividing by 2. Oh, no, no. So square buffer is the distance between squares. So we're adding half of that so that it's shifted over the same amount it would be if it was sort of midway between. Character diff. Yeah, that didn't help a lot. But it's good to know that it's there. So thank you for the suggestion. So yeah, so this is, if we come back to our README, actually. Um, so the one case is finding the midpoint between the edges of the blocks, and the other is putting the line sort of the appropriate position off the left-hand side. And so that is why that's there. And none of the rest of it actually changes, which is interesting. Um, yeah. And then trim white space in this instance, well, it causes it all to line up on the left, so it makes this a little easier to read. So that's a win. But it doesn't change the actual results. So, so actually the so having the first line, that's actually entirely reasonable. We just don't need to have all of them. So really, we could just put that and get rid of that and shift these guys all over one. We will definitely need to do that. I think they're going to be similar, but they're just off the right hand side. Yes. Interesting. So I don't think we need to declare it because this is Python, and you don't have to declare things in Python. I think the warning here is that because this has a condition attached to it, it doesn't know for sure that either of those things happened. It's possible that we did one of them, but we didn't do the other one, or we didn't do either one of them, and then CP1X doesn't have a value. Now we could just give it a value. Actually, we could just do this. Well, no, because then we do all that math unnecessarily. We could, but I don't want to. Ternaries make me cry. I don't like them. I mean, the question is, do we need to do this test? This is a place where if we knew that this was an unsigned integer, like in Rust, we would, if we declared this to be an unsigned integer and this wasn't true and we had some reason to believe it couldn't be more than that, then we would know it was 0 when we just skip them. But I think we stop it. I think we could just skip this and why are there 2 blank lines here? I don't know. Although I guess probably having one for a comment that explains what's happening here. In fact, making a function out of this would be nice. I like the idea of turning this into a function. Can we refactor extract method? Woohoo! First exo location. 'Cause, 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 Why don't we just always use the second one? Undo, undo. Oh, you know what? Aren't you smart? Yeah, totally. Totally, totally, totally. Yeah, just replace this 0 with CP1 IDX and skip the rest of this nonsense. Oh, come on. Ah, good catch. Yes. Um, well, I mean, it requires that square buffer be used in the way that square buffer is currently being used. Um, but I don't think that's an absurd assumption. Um, Especially since it does significantly simplify the code. So set the x coordinate of the first crossover line to be a little to the left of the. Ooh, hang on. Yeah, no, that's right. Um, yes, we are going to have to make sure it looks fine. Um, Maybe we should do that. Oh yeah, we could do that. Okay, and that looks fine. And then if we change CP1 IDX to 0, then it'll rerun. I just want to make sure. Yep, and that still looks good. Awesome. Boink. Put that back at 2. And thank you for reminding me that this side view thing existed, because I forgot that it was a thing. Oh, that's a good point. Square buffer. Change it to like 0.5 for fun. And there, that looks fine. And I mean, it looks awful, but it's doing the right thing. And that is doing the right thing. I wonder if there should be space here that includes square buffer, and that there isn't. That is an interesting question. Where do we see when we build gene? That's here. Oh, we set the buff to just be 0.3. So really, we want something that uses square buffer there. So it's like, and it was 0.1 before. So maybe this is, say 2 times square buffer. Oh, is that going to be self dot square buffer? Let's try that. It's weird that it actually pushed this text off. That was not great. Oh. So you think the genomes are centered and then the text is coming off of there. So it has some kind of fixed frame that everything's working in. Huh. I guess I was assuming it would create the frame to contain all of the stuff, but maybe not. Yeah, because it does look like this is centered. So that does look plausible. That it's centered and then we've pushed our text off to the side. Poop. So how do we get it to resize everybody so that everybody fits? I mean, maybe I don't care that much because realistically I don't want square buffer to be 0.5. I want it to be 1. I think it was working pretty well, but it still seems fragile to me. Yet it does place, I hadn't actually noticed this before, but it does place the genomes in the middle of the frame when really I want them sort of, I probably want them shifted over slightly so that the crossover diagram is more centered. Yeah. No, I think you're completely right. It clearly did center the genomes, and then everything else is placed around them. Take a look and do that placement on the V group, which contains everything. So where is the V group? So this is the V group that joins everything up. So here we're adding, this is the place that adds them to the scene. And can we say something? Oops. Don't add that. Instead, create a V group out of all of them and add that one instead. Oh. Sure. So put these together, stack them, and then make a V group out of those. I wonder if my concern would be if we look at the thing. Come on, you doing the thing? Yeah. I'm a little worried that it would then shift the child to the left, that it would center everybody. So can we write a line when we make the V group? That's or is that in range? Maybe that's in a range. It's Direction. Center. Yes. So I bet we can change. But that's not the same as alignment. Let's try your thing. Let's see what it does. So let's comment that guy out. Oops, that's not gonna be good. Self dot. Well, I'm guessing too. So, and it's that or read documentation, right? V group. Genomes group. P1 label. P2 label. Child label. Oops, nope, not that. Label. Meh. Try it. Oh, V capital G group. Thank you. Good catch. Boop. Oh. Well, that's weird. It's exactly the same. I think it's the same because the labels are placed like this is just the label parent 1 and its placement is relative to these guys. And so I think these guys are still centered. And comment out 98. Oh, I see. Maybe. Try that. Yeah, that didn't change it. Unless it needs to be rerun. Yeah, I don't think that changed it. So I think somewhere here I have document. Here we go. So let's look for align. Align data, align on border, align to. Call center on it first. So like center, like this. That might work. Fingers. Oh, look at you. Well done. Good job, Eustace. I like that. That worked very nicely. And so then I think we could go back up here and have our stupidly big square buffer, and it will, yes, nice. And actually 4 will probably even fit. Haha, look at that. Well done. Well done. Yeah, I'm okay, like, with the scaling the way that it is because I don't really want this to be this big. But it's nice that at least it's centering things in a better way. So I do like that. I think that's an improvement. Cool. Huh. It was 0.1. I'm just sort of playing around a little bit. So yeah, I'm kind of, 2 was a little too spaced out, but maybe 1.15 wouldn't be bad. Actually, I think I like 0.15 a little better than 0.1. So I think that's actually very cool. Well, we made an improvement. It is a better thing than it once was. So that is nifty. Um, and then presumably these are going to be the same. Yeah, I think we can get rid of the second if. That basically, let's see if we comment all of that out. We bring this over and we replace this with um, CP2 IDX minus 1 or CPX IDX and then use get left. I'm not sure. Okay. Now let's put this guy, instead of 6, we make that 10. Hopefully it'll just sit off to the right. Oh, we blew something up. Oh, it drew it correctly. Oh no, we're fine. I just got excited. Yeah, it did good. 9 should be in 1. Doo-doo-doo, doo-doo-doo, doodly-doodly-doodly-doo. Yeah, totally cool. Awesome. Doop, doop. Yeah, the ifs were just a bunch of noise. Oh, here we are. Wanna. Boom. Okay. Close you. So we're setting the x coordinate of the first crossover line to be a little to the left of the gene at CP1 IDX. And this set the x coordinate of the second crossover line to be a little to the right of the gene at CP2 IDX minus 1. Boom. Yeah, if I think there is, yeah. So we don't do any assertions about that, but if all this code sort of assumes, so the two crossover points will be to the right of the genes with the following indices. The code assumes CP1 IDX, let's see, 0 less than or equal to CP1 IDX less than CP2 IDX less than or equal to genome length. So I don't think the if on 19 does anything. And so I think we can just get rid of it. I mean, it just checks if the genome length is 0 and return, but it doesn't check for anything else. It doesn't check for negatives or whatever. So I think that it either should be expanded to do something useful or it should just be gotten rid of. Build the genomes. Oh, go away. So that gets our starts and ends. And we could, if I'm going to say it in the comment, maybe we should check it. Yeah. Assert. And I don't know that I've ever used assert in Python. I assume it does the obvious thing. Oh, and of course this isn't going to work. Although actually in Python, does this work? Self.genome length. Not wealth. Can you chain things in Python? I don't think you can. I don't think you can chain. Oh, you can chain conditionals in Python. I knew you could in something, and I couldn't remember if it was Python or not. But okay, if I can, I'll take it. And then actually this comment is kind of just a repetition of this assertion. So that's a good point. Yes. So it does implicitly check that genome length is greater than 0, which is nice. Okay. Woohoo! Now I bet. Okay, I'm actually going to go back to the diff thing. And is there a function here that wants to happen? Okay, stop. Come here. Boom. Oh, hello. How do I make you stop doing things? There we go. Or not. Oh, down here. Thank you. Good. Is this just going to be a bunch of 2s instead of 1s? Oh, that is what I wanted. Okay. Find differences. Let's go to character and trim white space. So it's a bunch of 2s instead of 1s, with the exception of the left and the plus versus the minus. Those are the only things that aren't just 2s instead of 1s. So I do feel like extracting into a function would make sense, because we would just pass in CP whatever, and that's going to take care of these guys. We would need to pass in this text or this number. So have it build both of them. No. I get it. So we get the line and the text, and we. And then okay. So we get the line and the text back, and then we would call the self.add and the self.play on those elements. Probably doesn't even need to be a V group. It could just be like a pair. Because V group probably does Manim thingies that we don't really need it to do. This bit here is a little awkward, because I don't think I can. It'd be nice if I could have just get left or just get right, but I don't think I can. So, I mean, we can take an argument, like you say, but just that irks me. If I could avoid it, it would be nice to. But I don't know that I can because the leftmost square. Yeah. Well, I don't know that I can do always left because then I would need to use CP2 instead of CP2 index minus 1. And if I use CP2, this indexing is going to fail because there isn't a thing to have a left over there. So I have a feeling um, that it's going to. I mean, I have to have some sort of conditional, in which case I think I might as well just have. Um, the might as well just have the left right indexing like you were talking about. Not thrilled about it, but I think maybe it's the thing to do. So let's try just extracting a function out of this. Um, Having a consistent indexing for the gaps might be cleaner. Yeah, so if we think about the indexing for the gaps, so 0 would be to the left of the first gene, and then 10 would be to the right of the last gene. So you'd go 0 to n plus 1, essentially. Well, 0 to n, but inclusive. Um, then we are being consistent about the. Maybe that is the thing to do. Well, let's try. Let's extract a function. Let's see what we can get here. Okay, and it just returned those as a pair. That's good. Oh, I should have. It gave me a chance to give this a name. And this is construct crossover. And let's go have a look at what that does. So it takes, so that's a terrible name now. Gap index, maybe. That should be just parent genes. Do we need that? Maybe. Then this is a bad name. Cross over. We could just say x coordinate. And this could just be the line. And this could be the text. And so we're saying get the parent genes go of at that position, go one to the left. So this is where we would need an if statement to check if we're kind of off the deep end. And then we get the dash line. And so let's see what you've got here. Copy URL. Ba-da-ba-ba-ba. So this is the same as here. Yeah, here. So I had that one open already. Oh, zoom out. Well, oh, there's another guy there. Okay, fine. Right. Yeah, that's what I was thinking about. Is that the indexing goes from 0 to n inclusive, and it sits. So basically, every line is to the left of the gene with that index. Or every gap is to the left of the gene with that index, with the exception of this guy that's sort of to the left of a fake 11 that doesn't actually exist. And so we'd have to, yeah, right, exactly. And so I think we can do that. I think that this will get us most of the way there. So we're sort of saying go to the gene with that index, which would be to your right, get its left edge, subtract the appropriate amount, and then we just need an if here. So if gap index less than self dot genome length, then do that. Otherwise, x coordinate is going to be parent genes self dot genome length -1 dot get right 0 plus self dot square buffer over 2. Oh yes, we're gonna have to do something about the text. Yeah, you're 100% right about that. Oh, yes, you're right. I can do just -1 here, can't I? Well done. Oops, helps if I have the minus. Yes, I think I can totally do that, which is definitely better. So that's nice. It avoids tying us to the particular length. I also could have done parent genes dot whatever size or length or whatever the thing is in Python, but this is better still. So that is nifty. Trying to figure out. So I guess we just pass label in. And this becomes label. And then up here we would add that back. Then does this work? Yeah, I have no idea if construct crossover is a good name. I'm bad at naming. This is not my strong suit. Well, it doesn't draw it. Like the drawing happens here, which we don't have, at least at the moment. I have that outside of the now we could move that in which case then it would be more like draw a crossover point, and then it doesn't have to return anything because I don't think, yeah, that's never used anywhere. So in fact we could just put the drawing in there and then call it draw crossover line. or visualize crossover. I draw crossover. So I actually kind of think moving this down here and skip the return altogether, because we don't use those components anymore. This is line. No, this is text. And this is line. And then this doesn't need to return anything. I mean, it does combine the calculating stuff and the drawing stuff into one. Oh, wow, Bali. Man, why are you not with them? That sounds way more fun than being here with me. Man, that's a stinker. Too bad for exams. I'm glad that they're there. I hope they have a wonderful time. My mother loved Bali when she visited many moons ago. I think it'd be like 30, 40 years ago, probably 40 years ago. But I have never been. So that is very cool. Okay. So there we go. That sounds like a plan. That'd be a hot, sweaty place to ride a bicycle, depending on time of year. But I think probably a hot, sweaty time pretty much all the time. Yeah, so let's rename the function. Hello. Visualize, no, draw. Draw crossover. Boom. Yeah, hot, sweaty region in general. No question about that. No, probably not. I mean, anything that's essentially a rainforest, well, by definition, is going to probably be a hot, sweaty place. So then, in theory, we should be able to say self.draw crossover, settle self.draw crossover, CP2, what is it? Hello. CP2 IDX, parent to genes, come on. And actually, I'll just steal all of this and remember to change the 1 to a 2 at the end. And then get rid of all of this. And no, you won't get hypothermia. There may be other things that happen, but you won't get hypothermia. Awesome. Now let's actually confirm that our edge cases still work. Hey, look at that. Blue. Cool. Oh, and I guess actually, realistically, it is possible for these things to be the same. It depends on how you want to implement things as to whether you want to allow that. Oh, but it does definitely messes up the deal. So I think we don't do that. Let's say that, and since this is just visualization, not implementation, and I assume if we put them too close together, the labels will just get in each other's way. Yeah, and that's just a graphic design problem. Oh yeah, what happens if the assertion fails? That's a good question. Um, Assertion. Something broke. Let's pull this up. Um, Assertion error. Executed return code 1. I think Manim is probably obscuring our issue here. I don't know what of all this. I guess this is probably the, yeah, this is the, oh, that's the command. So it really is this probably. Oh yeah, there we go. It pointed to the right line. I just scrolled way too far back. So yeah, it highlighted the correct line and said that there was an assertion error. So that's what it did. Yay. Oops. I don't want 22. That would also be an assertion error. Yeah, well, nothing's as good as Rust, right? I mean, sadly, pretty much true. But okay, so that cleans that up and makes that a lot nicer. So then, actually, I've got some comments here that really ought to be down here. Set the x coordinate of the first crossover line to be a little to the left of the gene at gap index. Here, the crossover line is to the right of the of all the genes. So we set its x coordinate to be a little to the right of the last gene. First crossover. Oh yeah, first doesn't make sense. Good catch. Thank you. Set the x coordinate of the crossover line to be a little to the left of the gene at gap index. Okay. And then this makes the appropriate dashed line. This sets the text up. And we add the text and we play creating the line. Oh. Okay. Oh, I didn't mean to do that. Okay. So, and here, so here our assertions tell us that CP1 is less than CP2. And, oh, okay, I see. This is just animating the 3 segments. And we say we don't want to do a segment if the index makes that segment empty. So when you say format the arguments, I assume you mean to draw crossover, and I assume you mean rename rather than format. Oh, to dash line. Sure. Because this got really long. Yes, we could do that. Is that going to work? let's actually sort of draw a crossover line or point. I mean, that's why I ended up just going with draw crossover. Um, but it isn't we're not drawing the act of doing the crossover. That happens later. Um, so maybe visualize crossover point. Visualize crossover point. Cool. Okay. And I do think breaking this up made that easier to read. Yeah, I think that was an improvement. Can I do that? Oh, just like that? And I probably, because white space is weird in Python, I probably can't shift those in without breaking things. Oh, hey, that works. Nice. Although you're talking about removing a level of indentation. Oh, you were thinking maybe moving the moving this guy to the left, so like that. Oh, that's better. Yes, that's nice. I like that. That's definitely an improvement. So I moved everything to the right when really we just wanted to move the closed paren to the left, which I think is nicer. So that's kind of nice. Cool. Well, there are clearly people that will debate this for a long time. No question about that. That is, the use of significant white space has, many people have had strong opinions. And I don't think I would use it if I was, like, I wouldn't vote for it per se, but I'm not against it as strongly as some people, such as perhaps you. I think, it's one of these things, once you get used to it, I don't know that I mind it. It's just like in this instance, I wasn't really sure what the rules were. And now I know something about the rules. So that's cool. Okay. So that extracts that. Oh, I guess we need to remove all of this. Don't need that. And I think we could get rid of those guys. So visualize the crossover points. I don't know that that's useful as a comment. I'll leave it out. Yeah, well, that's a fair point, right? That something like Rust Fumped can be quite opinionated, and it won't break things. You can disagree with his opinion, and you can customize its opinion, but it won't break stuff, and that's harder to do with Python. So that's a fair point. Okay, so we wait. That comment is entirely unhelpful. Does it actually matter which genes we pass? Probably not, because it's just using it to get a length in a couple of places. So I bet I could change this to parent one or child or something, and it'll still work. Yeah. So a possibility is, which I was thinking about, go away, is instead of passing this, pass this. And in fact, if we passed that and did the math right beforehand, then we could change this to be get rid of the if and just pass this position. Essentially, actually pass the x coordinate, compute the x coordinate in advance. Oh, no, we need this here. No, but that's the only other place. Yeah. So we could compute the x coordinate in advance and pass it in. And then not pass in parent genes. And it would pull the if out again. But maybe we want a second function that is the if part that computes the x coordinate, and then we call it, and then you would rather have the gene thingies be inside self. And then we would just pick one of the gene sets to use for our indexing here. That's a possibility. So where... So would build genomes just assign to self.parent1 genes and not return anything? Have this assigned to these self things and then not bother returning something, and then we just have access to them elsewhere? I'm not sure what you mean by call that outside a function. Like, like maybe put this up here, like that. Can we get away with that? Because this does this refer to self? Oh, it does refer to self. So that this has to be in the deal, and then that's not going to work. Yeah. Boom, 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 boom. Yeah, since build genomes depends on stuff that's in self, but we could just assign these in build genomes. I don't know that we can use init because I'm not sure how. I mean, Manim, I think, assumes that you're giving it the name of a type, a class that inherits from scene. Well, I don't know. I mean, I guess we could maybe. And no. Oh, we would just have to do all of these this way, which is okay. We could live with that. And this is going to have to be... Oh, that's that. I could do that. Yes. This is a place where, like, I bet if you told an AI the right thing to do here, it would just like do it for you. And it would be less. Oh, it would be less likely to do what I just did. pself.errant. And voila, try all that. Wada, wada, wada. Hey, look, that worked. Well, that's cool. And then we could do as you suggested, and down here we don't pass this, and we use self.parent one, or what is self dot parent one genes. There we go. That would do. Boop-a-doo, boop-a-doo, boop-a-doo. Oop, something broke. What isn't happy? Oh, we're calling with too many things here. Go away. Go away. Voila. Yes, and then we could move CP line Y, start and end into self, and then we wouldn't have to pass them. You could. I think I'm going to go ahead and leave them. Oh, I see. Yeah, no, right, because they're probably never used anywhere else, right? So move all this into the function. It gets computed twice, but it doesn't really matter a lot. Oops. Yeah, it's not going to be a big deal. And then this goes away. And we don't need self. Da 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 da. Here we go. Yeah. So this would really be visualize. Visualize crossover points. Awesome. And CPU, yes, probably. I don't disagree with you on there. And then all the parameters actually have left. If we move this up here, shift everybody over and lose this. We just get rid of the numbering. And then this becomes self. Hover over scene. We can do that build genomes in the setup function. Hover over scene. A scene is rendered internally by calling scene render. This in turn calls setup, construct, and tear down in that order. So we can use setup. So this is sort of like setup on a unit test. So that we can do the setup that in advance. So you're thinking, and was it set? Set up there. Okay, fine. So this would be Oh, do you not? Oh, that's interesting. Okay. And then self dot, little s, self dot, and there we go. Does that work? Yes, it does. Okay. So then your suggestion is that we would implement self or setup, and that we would then call like this. Here, for example. Well, I mean, I don't know that assert being there is any wackier than somewhere else. I mean, we're defining some constant. If they were arguments, oh yeah, I think it worked. Yeah. Oh, the assert. I see what you're saying. Oh, well, okay. That should break things. Yeah, it broke things. Presumably that's going to be an assert error or not. Yeah, right. Assert. Foof. Assert failed. So, yay team. Weird stuff, but it does work. Okay. And it is quarter till already. How did that happen? So let me think. So this turned out to mostly be some good refactoring that needed to happen anyway. So I'm happy about that. I like refactoring. I probably ought to fix the 22. Yes, that would be important. Thank you. That would have been bad if I'd left that there. Good catch. So that's a lot nicer than it was, I think. I think maybe committing would be a good idea. Wildcard import from a library is not allowed. Well, obviously it is allowed because it's working, but what if okay. That's strange, but let us commit. I think that would be a very useful thing to do because there is a lot going on here. We can factor out the animation down from genex to child in a certain range into a function. Yes. Yes. Right. That all of these start with an empty for loop. So actually it's particularly easy to see here if we take this and we go to your nifty tool. That's going to be over here. That's going to be here. That's going to be down here. Boom. And we grab this guy. I think all three of these are going to be pretty similar. Find differences. Let's go to character and trim white space. So that's just a number which is probably what needs to be returned. Or maybe not even returned because it's just being played. Do we care about the animations? No, we do not. So that's just a name. This is an argument, which would be the endpoints. This is just a name. Oh, no. Yeah, so that's going to have to be passed in. We could make the range and pass it in. That might be nice. Pass this in. That's just the local variable. That's been passed in. That's the local variable. Yeah, so we could easily refactor that. Let's actually do that quick, because that's not going to be too bad. And this is going to be the same, right? We just make an animation. We have a range. Yeah, I think this will all work. Gotcha. I actually missed that, so thank you. So let's see if we refactor, extract method, copy genes, I think actually is be a good name. Ooh, that's weird. Okay, so we're gonna have to do all the argument stuff for it. So this would be parent 1 genes and child genes and range. In this instance, we want self.cp to index self.genome length. So if we did that, and right, so we're passing both gene sets in. So basically we want these things, but probably renamed. Oh, actually, we just want the from genes. From genes to genes and gene range, I think. Oh yeah, thank you, good catch. Self dot and self dot. And so then, stop it. So that needs to be renamed just to be animations. This needs to be gene range. This needs to be this needs to be 2 genes. And this needs to be from genes. Animations append. From genes to genes. Oops, underscore. Did I lose my place? I think I did. 2 genes. And then play animations with a lag. 1, 2. First group, second group, and the one that matters. Hey! Look at that. Okay. So then we just want to replace these guys in these 2 places with the weights. And I probably want to steal this comment and put it here, maybe rephrasing it slightly. The target genome squared is the parent genome square. And then I've got another comment here that's actually, oops, go away, go away, go away. Is that comment useful? I don't know. Let's have a look. I don't think that's helpful. I think that comment just disappears. Okay, and then we call this function here. So self.copy genes, self.parent1 genes, self.child genes, and range self.cp1 idx. And then the rest of that should be able to go away. Does that work? And first one down, second one down, third one down. Awesome. Then we do this one more time. Here, self.copy genes, self.parent2, self.child, range self.cp1 idx, self.cp2 idx. Boom. And it works. Much better. Much, much better. I'm very happy with that. Okay. Oh, go away. Nice. Now, so now we really are at commit, unless, do we care about the order of these helper functions? Because they're probably in some kind of randomish order here. Copy genes. So yeah, so this is kind of the last thing. They're in some kind of semi-reverse order, which probably doesn't make a lot of sense. So in fact, I think if we put these two guys, yes, I do think it is a good refactor, and I am very happy. I'm going to actually move these guys to the bottom. I mean, I'm probably overthinking it here. And then put this guy at the very bottom. Make sure it didn't break, and it did not break. Look at that. Nice refactoring. Certainly make doing other crossovers going to be a lot simpler, I think, with this refactoring. So I think that's a definite improvement. So let's commit, and we'll call it a day. I didn't actually do this in a branch. Maybe I don't care. Yeah, and I think that's probably, I think that's true for most people now, myself included. I still remember when we printed code and read printed copies with, a pen in hand. And so I think this is probably me caring about stuff like that. And then you can think of like, well, I was about to say it was pretty terrible, but oh yeah, much better than punch cards. It was. I mean, I think it did cause you to stop and think in ways that modern IDs tend to just encourage you to type. And so I think that it did have some advantages, but not enough that I want to go back to it, to be honest with you. But it was a thing that I did a lot of back in the day. And then you have languages like Pascal where you couldn't use anything until you'd already defined it, so the sequence of definitions was crucial, which I guess C has that property as well. You have to define things before you use them in C. So if you have mutual recursion, you have to do the weird, like, declare the thing. Yeah, so C is the same, whereas C++ is not. So, yeah, header files for the win, right? Okay, so we made many changes. And is there something to say here other than any many changes? I wonder. Maybe I don't actually commit this right now because so Git Kraken, the latest version. Yeah, that I'm not shocked that you had C homework that was created by people who don't write C. I think that there's the set of people that write C in a serious way is small and very focused. I think, and probably not faculty for the most part. So, yeah, be prepared for that. Oh, really? Wow. Because I mean, the if and def header thing it's an ugly thing to look at, but it's pretty necessary to like get anything done. Uh, yeah, so that's depressing. Again, you had all this stuff set up, and then they didn't play along. Um, but the fancy new version of GitKraken Pro has AI stuff for like doing commits and things, and yeah, a little bit. And I have historically had a pro membership through the GitHub Student Pack, and for some reason that's like broken for me at the moment. And I checked, and my colleagues, it still works for them, so it's a me thing, and I need to do something about it. And so I might actually do something about it and then try to do this, because one of the things that they say they'll do is suggest sequences of commits. Like if you make a ton of changes and don't commit along the way, like we did today. There were a couple moments of like, oh, we should commit here, and then I didn't do it. It would be interesting to see if GitKraken could, in fact, suggest a sequences of commits that would break this set of changes down in a meaningful way, or whether it would mostly just throw up its hands and go, "You changed things." And so I might try between now and next stream to see if I can get my GitKraken Pro to work and see what that actually looks like. Yeah, I mean, I think that the university probably just is assuming, probably correctly, that most students don't have a lot of environment set up. And so and so I think there's two pieces there. One, they're going to, in places, tell you, yeah, it might just be a matter of relinking, but I feel like I've done that and it hasn't worked. So I'm not sure. So one, they're going to want to like help people get set up, and if they don't set up the way you are used to things being set up, that's going to be bad. And the other is they probably just are doing certain things without realizing that there are setups out there that would break things, like the if end if and hash define. I mean, they really ought to just be using those, and your setup is surfacing the fact that that's a gap. But yeah, so so I think, I could try to do. No, it's probably in default profile or something. No, it's probably in preferences. I'm not going to mess with that here because I'll probably end up having to log into a bunch of stuff and it'll be like insanity, and I'll do that offline. So tomorrow, 10 to noon, CDT, UTC -5. More readmes, etc. in Unhindered EC. I feel like we've got. Do we have pull requests that need to be dealt with? Reload. I feel like, is there a pull request that's dangling? I guess it's just this guy continues to go on, and then we've got this guy dangling around too. So we really want to see if we can finish that readme business. That would be a good thing to get that pushed in. And then yes, and we have your big thing to take care of as well. And then I think, let's see, am I right about this? Is next weekend going to be well behaved, or does something funny happen? I think next weekend is going to be well behaved. Yes. Aha. So next weekend is normal. So Saturday, 2 to 4 p.m. CDT. Oh, I guess a date would be useful. That would be 26 July, 2 to 4 p.m. CDT, UTC -5. More animations in Manium. So, it's totally fine. Whatever you're doing is volunteer and appreciated. Everybody's contributions, such as they are grateful. So, yeah, well, I think that's entirely reasonable. And Bali must be, well, actually for you, because I'm guessing Bali is probably 10 to 12 hours from me. And so then it must be not so +8. Okay. Yeah. Yeah, I think the most difficult that I've had was Japan, which was +10 for me, or -10, or plus, I guess it would be +14 for me. Yeah, to avoid the dateline. So I think it was +14, but I always thought of it as 10 hours difference. And that was, I was getting up about the time my wife was going to bed, and vice versa. So we could chat for a little bit when I got up in the morning, and then we could chat for a little bit before I went to bed. But much of the rest of my day, she was asleep, and vice versa. So, yeah, totally. And the fact that the dateline is this wildly polygonal, crazy thing is, yeah, there's a lot of history and politics there. Very weird. So, okay, well, that was awesome. Thank you all very much. That was, I think, a super good refactoring. I was very happy with that. And I will let everybody go, and I will see some of you tomorrow. We'll talk to you later. Goodbye.